I didn't even notice I didn't record until the end of last hour. Okay, so the two topics we have left in this unit, they're 100% very different, and they have almost zero to do with related rates. So, whether that's better or worse. The main reason they're in here is, wait, hold on. I'm just muting a bunch of people who didn't. My screen was different. Okay, there we go. So these topics don't really fit in with any unit, but they deal with derivatives, and so that's kind of why they're just put in here, right? So they're somewhat used on their own. So the local linear approximation is super easy. It's just a single little formula you have to write down. Okay. The second one is called L'Hopital's rule. And I've heard it pronounced differently. I've seen it spelt differently. The one right here is probably the French spelling, because I believe that little caret is the French symbol. I'm thinking Le Hospital is the Americanized version. But as far as I know, it's pronounced L'Hopital. I've also heard L'Hopital. Doesn't matter how you say it. It deals with limits, so I'll show you that. It's not bad. Here, let me... That was a super awkward unmute there, guys. All right, local linear approximation. So, here's the purpose of it. This topic itself, I really don't agree with or even see the purpose for it, but, it's on the AP test, so I'll teach it to you. So the idea behind it is this is supposedly, what you could do without a calculator if you don't have one, right? Let's say you're asked to evaluate 1.97 on some sort of a crazy hard function. Well, you don't have a calculator with you, that's not really going to happen. So one thing you could do is, if there is a easy computational location close to it, like say in this instance 2, you could use x equals 2 and the slope at x equals 2 to help you figure out about where f of 1.97 should be. So this is the way the formula is written and kind of deciphered. L of x, so L for the local linear approximation, L of x is the difficult number you are trying to evaluate. So x is the hard number. You could find it by evaluating a number close to it that is easy, and then taking the slope times how far away from that number it is. So that's the way this formula is written. So what I wrote in pink is an example of a question you'll get on local linear approximation. Find g of 5.1 by using local linear approximation at x equals 5, being given that g is differentiable function. So, like in this instance, we're not given the actual function, we're just given information. It has to be differentiable because of the slope portion of it. Just basically saying it's continuous. So if we're given g of 5 is 8 and g prime of 5 is 0, find the local linear approximation at 5.1. So the way we would do this is we would do f of, oh, excuse me, I'll back up. G. We would do G of 5, because that's the easy information, plus G prime of 5 times how far apart 5.1 and 5 are. Now for this one it's easy because the slope is 0. So G of 5 we were told was 8. Slope of 0 times 0.1, which would give us an answer of 8. So our estimate of G of 5.1 would be 8 using the approximated method. So this is the first topic. And I'm going to guess you're okay with this. Absolutely ask away any questions if you have something. Maybe I forgot to say something, or maybe I skipped something, whatever. I didn't feel like we needed to do examples of this one because they all follow that exact same formula. So if you guys are creating a note card for the test, or for your homework, whatever, make sure you put that blue equation down. I tried writing what X and C were for so that you guys would, put little notes to yourself, because that 3 weeks from now, if you need to go look at this formula, you are not going to remember what X and C represent. So that's why it's a good idea to write little notes to yourself. Anybody have any kind of questions on what's up there so far? Anything you want me to, talk about? That doesn't matter to me. Okay. So L'Hopital's rule. L'Hopital's rule is a way to evaluate limits that are in an indeterminate form. But it involves derivatives, so we couldn't teach it to you in the limits chapter or unit. It's kind of a weird, go around here. 3 years ago, I believe it is now, AP used to teach L'Hopital's rule in Calc BC instead of Calc AB. But then they swapped 2 topics, and I'll just tell you, you guys got the better of the deal. L'Hopital's is really easy to calculate and to do. Now, last year, the College Board kind of purposely put on a workshop that they wanted all the AP teachers to come to. And so when I went to it, I found out that a majority of the workshop was because they want to tell everybody how to write the answers to these problems. Because they found that nearly everybody was writing it incorrectly. And so they're making a main point of emphasis. Even though these are easy to do, the only reason that this is going to take a little while for me to go through this with you is because of the way the notation has to be written. Okay? So, it's an easy topic, but I just want you guys to get in the habit of how to write it. Who should we go with? Let's go with Darren. Darren, are you ready to start us off today? What? Nothing? Emma, Slavin. Is it Slavin or Slavin? Slavin, right? Wait, is my mic not working? Or my headphones? I can't hear you if you're talking. Oh, shoot. I thought something might go wrong when my headphones died while I had Zoom open. Anybody else? Maybe we'll get lucky and it was just one microphone. Jackson? You there? Wait, can you guys hear me okay? Okay. Does anybody want to volunteer for this one? You guys don't even know what you're being asked yet. Excellent. Okay. Do you remember why we couldn't do this one in the limits chapter? Or do you remember what the first thing we always tried with limits was? It was that long ago, huh? Okay, so the first thing we always tried with limits was to plug the number in to see if we can get an answer. So that's always the first step. Okay, good. So on this one, if we plug 0 in, we'd get 0 over 0. And this is called an indeterminate because you can't get an answer out of that. Well, what I just wrote is what the AP says is wrong. So this is why they marked it wrong for apparently like 95% of students who did these questions. And I don't agree with it. It doesn't matter what I agree to. I'm not the one scoring the tests. I'm not the one that's putting on the test. So we were told that you're not allowed to write equals 0 over 0 because 0 over 0 isn't a possible answer. So the whole fact of writing equals apparently makes it an issue and is what makes it wrong. So here's how you have to do this, and it's dumb. So say you plug this in your head. Oops. There we go. What you have to do is you have to say the limit as x approaches 0 of sine of x is 0. You have to say the limit as x approaches 0 of x is 0. This creates an indeterminate form. Now, we were just given this answer back in the limits chapter or unit. What you can do, and what L'Hopital's rule says you are allowed to do, is if you get an indeterminate form, you are allowed to take the derivative of the top and the derivative of the bottom separately until you can get a correct indeterminate answer. So, underneath here, I would then have to say the derivative of sine of x equals cosine of x. I would then have to say the derivative of x is 1. So my original limit is equal to the limit as x approaches 0 of cosine of x over 1. And now I can plug 0 in and get an answer, which would be cosine of 0 over 1, which is 1 over 1. And I will 100% say that this is so much overkill for this problem that to me I don't understand why they want it like this, but it doesn't matter why. If they're the ones grading it and they're telling us that you have to write it like this, write it like this. These are going to be easy questions for you to get an answer to on free response. Like if you get this on free response, you're golden because these will be points you'll get correct. You just have to make sure to write it correctly. How about this question? Something you guys want to ask me about. Okay, you guys are awfully silent today. Totally just popped in my head because I got a message on it earlier. Did you guys have any questions about the going back to school thing? So most of you will go back on February 16th. Some of you go back March 1st. Do you guys have any questions on that or trimester 3 or anything? It still is, correct. So VLA goes through the end of the year no matter what. If you want to stay in your current choice, you don't have to do anything. So if you were a school option before, you'll stay school option. If you were VLA before, you'll stay VLA. If you want to switch to one or the other, then you have until February 7th to fill out a little Google form on the Sawashko page. When we're at school, we have to be on Google Meet for this class. And how will it work for VLA kids? Yeah, I actually have no idea yet, to be honest with you. So I haven't been told by the district if I'm supposed to be back or not yet. So my guess is Calc is stupidly hard if you're not learning it live. Trying to learn Calc over a video is not a good option. So whether I'm at home or whether I'm at school, my plan is to teach live every day during the class hour. And so if I'm in school, then I will, teach live so that whether you're at home or not, you can watch it and learn from it and ask questions. If I'm still at home, then I'll still teach it live, just because that's kind of what works best. Nobody can require whatever things, but you'd want to, obviously. And same goes for third trimester. So, we're at school. Oh, yes. So, yes, if you'll probably be using Google Meet or Zoom or whatever, somewhere for them probably. Switch to VLA right before VLA become mandatory. So, Vincent, if you did the actual switch to VLA, like if you filled out the form to switch, as far as I know. Oh, actually, you know what, Vincent? If you ask me, if you stay after class for a minute, I can open up the attendance sheet because it shows me on that. AP test the same time. As far as I know, it is. I don't think the AP test actually has anything to do with what school form we're in. I haven't been told anything about the AP test, so I don't know details. All right, well, if something's pressing, you guys are, you're welcome to ask me questions and send me messages, and, I'll help you out however I can. Okay, nobody asked a question on this, so I was assuming it went okay. Let's just go to another one. I think I got 2 or 3 examples here. Oh, yeah, okay, 2. All right. Jesus. Cat is not happy. Nobody's paying attention to her. So the one in green. So the limit as x approaches infinity of 3x over 8x plus 2. The infinity ones are kind of strange, because I taught you guys, and Mr. Stouffer taught you guys how to calculate infinity limits without knowing L'Hopital's. L'Hopital's is just going to be an easier way to evaluate infinity limits now, to be honest. So the method that I taught is kind of called somewhat discrete math, because it's kind of a non-official way to do it. So L'Hopital's is going to be an official way to find answers. So we'll start with, we have to plug infinity in to see how it goes. And this is the part I can't stand, because it's just so much extra writing for nothing. So the limit as x approaches infinity of 3x is infinity. The limit as x approaches infinity of 8x plus 2 is infinity. This makes it an indeterminate form. Ooh, computer's got to catch up. So because it's an indeterminate form, I'm going to apply L'Hopital's rule. So L'Hopital's rule is to take the derivative of the top, what's going on here, which is 3, and the derivative of the bottom, which is 8. Now, by using L'Hopital's rule, I can rewrite my limit as the derivative of the top and the derivative of the bottom. Now, if I plug infinity in, there's no place to plug it into a variable, so the answer is 3/8. How are we on that? You guys, what I want to specify, because maybe you didn't catch this, this correct notation writing stuff is if you have a free response question. If you have a multiple choice question and you guys get this, I would bet a lot of you could look at this and know the answer is 3/8 right away, and you could just answer that right away. If it is a multiple choice question, you do not have to show anything about how you got it. Okay, I'll do the second one with you and show you what happens if it doesn't work the first time. So infinity. So if I do it in my head, I know I'm going to get infinity over negative infinity, which is an indeterminate form. So I'm going to have to write it out. And the limit as x approaches infinity of x minus x cubed would be negative infinity, because this would be infinity minus infinity cubed. And this is an indeterminate. So because it's an indeterminate form, I can use L'Hopital's. And then the derivative of is 14x. The derivative of x minus x cubed is 1 minus 3x squared. So, oops, wrong color. So my limit can be rewritten as the limit as x approaches infinity of 14x over 1 minus 3x squared. Well, if I plug infinity in my head, I get infinity over negative infinity again. Great, fun. So what this means is, since I have another indeterminate form answer, I can keep doing L'Hopital's rule until I get a normal answer. So the limit as x approaches infinity of 14x is infinity. The limit as x approaches infinity, 1 minus 3x squared, is negative infinity. Indeterminate form. I'm just going to start abbreviating more. And then I apply L'Hopital's one more time. And the derivative of 14x is 14. So there's a good chance that I will now get a normal answer because I have a number as a derivative. 1 minus 3x squared would be negative 6x. And because of L'Hopital's, it is now equivalent to 14 over negative 6x. And if I plug infinity in, then I would get 14 over negative infinity, which is 0. Actually, let me back that up. Because the top number is so much smaller than the bottom, the answer is 0. And if you wanted to, if you felt like it, you could probably do derivative one more time and get 0 over negative 6. So this is how L'Hopital's is set up. They're not bad to do. Obviously, what could make them horrible is the derivatives. So I put two up here that I thought might be a good idea for you guys to try. They're basically more difficult, but the idea is the same. Partially for you to practice correct notation. So how about we say 5 minutes? Because I'm going to guess at the end of 5 minutes, you're going to get what you can or not, probably. So I'll mute myself for 5 minutes. Try them out. I guess I didn't even think about it. Did you guys need a reminder what the derivative of ln of x or e to the x is? Derivative of ln of x is 1 over x. I'm not even sure where to put that. So Haley, did you remember the product rule for x ln of x? Do you think you could remind me what it is? Perfect. So first derivative of second plus second derivative of first. And then x times 1 over x is 1. So it's 1 plus ln of x. Now, I mean, maybe I should start with what I wrote too, but thank you, Haley. So you guys should have gotten an indeterminate, because plugging in 1 gave you 0 and 0. And my thoughts was the product rule was probably the hardest part for you during this one. And then once you get 1 plus ln of x over 2x, if I plug 1 in, I get 1 plus 0 over 2 times 1. So I end up getting a normal 1/2 answer out of it. Before we move on to the second one, does somebody want to ask me any kind of questions about this one? X ln of x? Sure. I'll write it bigger here over on the side. So if I'm doing the derivative of x times, I've got two different variables being multiplied, so I'm going to use the product rule. So the product rule, we did it back in trimester 1, we used f and g. And so a lot of people memorized it as fg prime plus gf prime. So if that's the way you learned it, it still works the same. Other people learned it as the first item times the derivative of the second. So the derivative of ln of x is 1 over x plus the second item, or g, times the derivative of the first. So I simplified that into 1 plus 1 ln x. Is that kind of what you were looking for? Okay, no problem. Okay, let's start the second one. Well, if it's not an indeterminate, then I shouldn't have put it as an example for this. So I'm going to guess it's indeterminate. So 1 minus e to the 0, which would be 1 minus 1, which is 0. On the bottom, we've got ln of 2 minus e to the 0, which would be 2 minus 1, which would be 1. Ln of 1 is 0. So both the numerator and the denominator are 0. So 0 over 0 is an indeterminate. And once we know it's indeterminate, then we can apply L'Hopital's rule. The derivative of 1 minus e to the x. Derivative of 1 is nothing. Derivative of e to the x is e to the x. So the negative sign would stay on it as a multiplier. On the denominator, this one's worse. Ln of 2 minus e to the x is going to be 1 over 2 minus e to the x times derivative of 2 minus e to the x. So this one is chain rule, which would be negative e to the x. Okay, so I'm actually going to have to simplify this one. Oh, not 1, 0. So my numerator is negative e to the x over 1, because my denominator is a fraction, so that's why I'm writing it over 1. And instead of dividing by the fraction on the bottom, I can write it as multiplying by the inverse. So negative e to the x over 1 times 2 minus e to the x over negative e to the x. And those reduce out. And 2 minus e to the x, if I plug 0 in, would give me 2 minus e to the 0, or 1. Okay. Now, sorry, again, ask away if you have some questions on this. Hardest part is probably just remembering all the derivatives for you. Can I scroll down, or does somebody want me to leave it up here yet? Okay. I put this example here because this is an example of a L'Hopital's question that you could get on the multiple choice portion of the test. This would not be on free response because it would just take you 15 minutes to write. So if I put infinity in, I would get e to the infinity, which is, so this is scratch work. This is not official notation. So if I put infinity in, I would get infinity on top, infinity on bottom. So I can do derivatives. Well, derivative of e to the anything is going to be e to the anything times its derivative. And 4x cubed. Well, not surprisingly, this is going to be infinity still because this same thing is still there. So top is infinity, bottom is, well, infinity. So then I do derivatives again. And now you can see why the bell question. The top would be product rule. Now, the derivative of e to the x squared is still going to have e to the x squared in it, right? So the top is going to have e to the x squared every single step no matter what. The bottom will always take a normal derivative. So what I'm going to do is I can see this pattern happening, and I'm going to follow the pattern until I get a one that's workable. So the top is always going to be infinity because of this e to the x squared, but the bottom wouldn't. So the bottom would turn into 24x next, and then that would still be infinity, but I could do the derivative one more time, and the bottom would turn into 24. So after a few steps, I can tell that my answer is going to be infinity over 24 by recognizing patterns, and infinity divided by a regular number is infinity. So this would be a multiple choice style L'Hopital's question because you're not actually expected to do all of it. Like, it would take forever to find out the derivative of the top repeatedly. But once you recognize that the top is never going to change answers, then you can just work with the bottom. So, and like I said, this one would be just dumb if something like this was on free response because it would take so long. Okay, that's my 2 topics today. Do you guys, I put the test outline up on the weekly calendar for you guys, and like I said on the weekly calendar, you ignore this part. That was for last tech semester. Do you guys have any kind of questions about what's up here? My plan is to go over the outline with you on Monday during class, and then have you take the test sometime Monday, kind of at your own leisure. Now, because we're not going to be doing it live together, it's really important that you guys show everything and anything on your work. So you're kind of expected to be done with Khan Academy by Monday if you can. I will be grading Khan Academy Tuesday morning. So, and I'm not going to be taking late submissions just because there's too much stuff going on this trimester that it's not even a good idea for you to be working on it after the fact. So, Khan Academy, whatever score you have on Tuesday morning, I'll put in. I will take a look to see if there's any kind of a score I should add to yours or anything like that, and I'll let you know ahead of time. But Tuesday morning is when I'll check Khan Academy. Anybody have any kind of... Oh, sorry. Saw this up here now. Will this stuff be one of our FAQs on the test? Yes. Caduce number 4. Are you still adding a certain percentage? Kelly, yes. Don't know yet. I want to say we cover everything in Unit 4 in Khan Academy, so I don't know if I need to add a score, but we'll see. All right, you guys are awfully quiet today. Well, we got done 20 minutes early for once, and I figure you guys would kind of enjoy that on a Friday, huh? Oh, is our percentage on Khan Academy our formative score? Yes, it is our formative score. I did not say that out loud. Yep, your tests are your summative score. Your homework in Khan Academy is formative. And honestly, the Khan Academy is the entire formative category. All right, I'm done. I will see you guys tomorrow.